Okay, let's take a look at breaking some vectors into components. So we have vectors A, B, and C given here, and we want to find their components. So starting out with vector A, there's a couple right triangles we can make out of it. We can make a right triangle here, right? Kind of as given like this, where this 37 degrees is kind of measured clockwise off of the vertical here. And kind of just solving this, we would see, this is our opposite side, right? So this leg right here would be, we can call this AX, right? This would be, because it's in the X direction there, right? This AX is going to be, since it's opposite, it's going to be the hypotenuse times the sine of 37, right? So this is going to be the magnitude of A times the sine of 37, right? So that's using one triangle there, or, and actually, let's go ahead and do AY as well. So AY, now this is going to be our adjacent side, adjacent to this angle, right? And so we'd have, this is AY, and AY would be equal to, this is going to be the hypotenuse, or the hypotenuse, which is the magnitude of vector A times the sine, or sorry, times the cosine of 37, since it is the adjacent side there, right? So this is going to be magnitude of A times the cosine of 37. Okay? So, that's how we can get the components from that triangle. Or we could use a different triangle, and this might be more comfortable to many of you because I kind of put it in standard position here. If I make a triangle like this, so if I make a triangle that looks like this, then I'd have my angle here would be, was this 90 minus 37? We have 53 degrees, right? And this would be in a standard position. So I could actually say here vector A is 12 meters at 37 degrees, or I could say it's 12 meters at 37 degrees clockwise off the vertical, right? That's two different ways I could describe vector A in words there. But yeah, if I solve this green triangle, I would have AY, and this would be, now I have the y component is the opposite side, right? So that's going to be A times the sine of 30, or sine of 53, which A sine of 53 and A cosine of 37 are the same thing. You can see that in the triangles here. And for AX, we would have, this is the magnitude of A times the cosine of 53. Okay, so any way that you want to solve that is perfectly fine. You're just solving triangles here, so you can solve it any way that is most comfortable to you, or solve it multiple ways and make sure they're the same. But we have here AX is going to be, now the magnitude is 12, right? So I'll say this is 12 times the cosine of 53, or this is 12 times the sine of 37. And by the way, I'm using reference angles here as well, right? If we had something in another quadrant, we could, and we're using reference angles, we'd adjust. We'll see this in a minute. And so this is equal to, we have AX is 7.22 meters. I'll carry extra sig figs typically in calculations, just so you can use those to validate your work. AY, and this is going to be the magnitude of A again, which is 12. So this is 12 cosine of 37, or this is 12 sine of 53. Again, same thing here. And AY we have is 9.58 meters. the units of the components would be the same as the units of the vector, the magnitude of the vector itself, right? Okay, now B, we can say here vector B, erase some of this stuff. Vector B is a couple ways that we could write or say this in words. I could say this is 15 meters at negative 40 degrees, right? So the negative would mean a clockwise versus a positive is counterclockwise. And if you don't say any direction, it's assumed it's in standard position. So I could say vector B is 15 meters at negative 40 degrees. I could also say vector B is 15 meters at whatever angle this is. That's 360 minus 40, 320 degrees, right? So vector B is 15 meters at 320 degrees. I can say that. I could say vector B is 15 meters at 40 degrees clockwise off the horizontal. That'd be okay. Or vector B is, what's this angle here? This is 50 degrees, right? Vector B is 15 meters at 50 degrees counterclockwise off the vertical there. But it's probably easiest to say that it's in, just a standard position here. It would be 15 meters at 320 degrees. Okay. So if I just put it in standard position, I can actually always just kind of remember that the x component is going to be cosine and the y component is sine. And using the 320 degrees, any sort of adjustments I need to make for the quadrant will be done by your calculator. So it's kind of a nice little thing to use there. But I could also use 40 degrees, and then I can adjust for the quadrants accordingly, right? So I know that bx here is going to be equal to what's magnitude 15 meters times the cosine 40. So this is 15 cosine 40, but because I'm using the reference angle of 40 degrees, I need to make sure to adjust for the quadrant, right? But fortunately I'm in the fourth quadrant, so I know x is positive anyway. So I have bx is equal to 11.49 meters. If I do the same thing with by, we have bx would have been like this. This is by, right? By, let me move it over a little bit. By, this is going to be 15 times the sine of 40, right? But I have to be careful here because I'm in the fourth quadrant that it should actually be a negative out in front. I should have left some room there. By equals negative 15 sine 40, and this is negative 9.64 meters. Alternatively, we can say that bx was equal to the magnitude of b times the cosine of 320 in standard position, and that came out to the same 11.49 meters. Or we can also say by is the magnitude of b times the sine of 320, and your calculator will recognize the 320 degrees is in the fourth quadrant and adjust the sine appropriately, and this will come out to negative 9.64 meters. So either way, like I said, it's good later on if you can solve triangles, though. You're not always going to be able to put everything in standard position very easily. So kind of use the standard position sort of just to double check. Try to solve the triangles first. Taking a look at C, I'll do this one maybe a little bit more quickly here. C, we have a couple ways I can say this. This is 6 meters at 60 degrees counterclockwise off the horizontal, or I can say this is 6 meters at, what do we have here, 180 plus 60, that is 240 degrees, right? So 6 meters at 240 degrees. Or, so I can use the 60 degree reference or just the 240 in standard position there. If I use the 60, I'll need to make sure to adjust them in a third quadrant, so both the x and y components should be negative, right? So cx, a couple ways that I can write this. Cx is either going to be negative magnitude of c times the cosine of 60, which is the same thing as the magnitude of c times the cosine of 240, which comes out to negative 3 meters. And for cy, this is negative magnitude of c times sine of 60, which would be the same thing as just the magnitude of c times the sine of 240. And again, let that your calculator do the adjustments, and that's negative 5.20 meters. You should always think about it, though, in your calculations, which quadrant you're in, and make sure that it's agrees with what you remember from your trig classes.